Our next speaker is Vili Haukkovaara, Development Manager here from the National Archives, and he's going to tell you about the READ project.
Yes, thank you, Maria. Hello, everyone. It's nice to see so many people here today. So, as told, I'm Vili Haukkovaara, Development Manager here in the National Archives of Finland, and I'm going to tell you something about the Finnish approach concerning the recognition of handwritten text. And we can say that I'm talking about the READ project and our role in it. So, in short, I will go through just some basics about the READ project in case if someone of you is not familiar with the project, so this won't come not straight from the bushes or so. And then I will tell you a couple words about our role in the project, and then things how we have handled this role, what we have done, and what kind of results we have at the moment in the project. And also the things we have learned and how we see our role to be after the project ends. So in short, the READ is a project concentrating on recognition and enrichment of archival documents. It started in 2016 in the beginning and will end in mid-2019. It's part of the Horizon 2020 program in research and innovation infrastructures part. We have at the moment 14 partners in the project, a couple of archives, I'd say 3 archives, and if I remember correct, 9 partners are technical universities or universities, so it's a really research concentrated project. And if there would be a one line or sentence, what's the core mission in the project, it is that we're trying to make the archival material more accessible through the development and dissemination of automated text recognition, and mostly on automated recognition of the handwritten texts. So the aim is in the READ project is to build a virtual research environment, and this picture is trying to explain or simplify the thing we are building at the moment in the project. So on the top and low and left and right, you see the pink boxes. Those are the stakeholders of the virtual environment, and in the middle, in the blue, we have the READ platform and what it consisted of. If we see or look at the stakeholders, for example, archives, as we see ourselves here in Finland, the idea is that the archives provide material for the platform. And when the material or the images are provided, then we need humanities scholars or volunteers to provide information about the material, and it's called ground truth, and what we need to provide is ground truth for the computer scientists and companies who build tools for identifying or doing the layout analysis for the pictures, and tools and algorithms to recognize the handwritten text. And after this recognition has been done, we can provide back for stakeholders different kind of services. For example, as an archive, we can download back the material as enriched. For example, we get the content in machine understandable form. So we don't just have pictures and some handwritten writing in the pictures, but we also have the text in machine understandable form, and we can do something with that. And we can also, from the platform, we can provide different kind of interfaces for humanities scholars and public users where they can search for the content, like full text search and fuzzy search and so on. So what are the goals, our goals as an archive in the project? We have 2 major goals. and both are related to so-called large-scale demonstrators. The other part is related to crowdsourcing. So the basic idea is that we need to involve lots of people related to our material, interested in our material, and get them to do the transcribing and producing the ground truth that we need to create the models. So we need to have people to write for the machines and computers that, hey, there it says car from that picture, and it is written down there. The other goal is related to our role as a kind of not a big archive in European or global level, but as an archive which has a kind of large amount of digital material, plus 70 million pictures at the moment. So we have lots of material, and one aim in the READ project is to test how we can handle large and huge collections, what it would take in order to do the layout analysis, to figure out where the texts are located in the pictures, or do the handwritten text recognition, what it would take from the computer power and so on, how we can handle the whole process. So basically, these two tasks relate to each other from model to text recognition. So the more we get people involved and produce transcribing ground truth, the better models we get, then we can do better text recognition. So then a few words about the crowdsourcing, how we have approached this since the beginning of 2016. To be honest, when the project started at 2016, we were a new partner, and we had very not that good clue about handwritten text recognition and what it would take, what kind of steps it would need to do, and so on. So before we could even start to think what it would mean to have some kind of crowdsourcing platform and kind of demanding from our customers to produce ground truth transcribing, we needed to figure out that what we would expect from our customers or our stakeholders who use our material. So we did some in-house testing and learned a lot during generating a couple of models. We learned what it would take and how work intensive it is and how much work hours or transcribing hours it would take. And after we did these tests, since then we have had a couple of two successful crowdsourcing so-called mini projects, one with the genealogists and one with the university students from Turku. Next, I will show you two examples. One example is, well, there is not going to be a presentation when it's not going to mention something about war material. So one example, what we did ourselves in-house concerning the war diaries, and then the crowdsourcing example with the material produced by genealogists. So here is an example of the war diaries from the 1940s, and it's pretty nice handwriting. The biggest challenges in this material was that there is a lot of abbreviations and lots of hands who have written these texts, so these bring challenges in the model generation and the working of the models, how we get better results. In the first case, or this wasn't the first, but this was one of the cases we tested ourselves, what it would mean in order to produce models for handwritten text recognition. We produced 300 pages of ground truth, meaning that we transcribed 300 pages, these pages, and then with this material we generated a model, and then we tested the model, how it would work. And in the READ project, it has been really hard to make a measurement for the models if it's good or if it's not good. But in the end, we have had a conclusion that maybe the best way is to concentrate in this CER, character error rates. So it means how many errors there are in character recognition. So basically this 22% character error rate means that every fifth character is interpreted wrong by the model. And here's the result. Sorry, just one thing. About these models, we can have different results, and usually it goes like that. We had this 300 pages and got character error rate 22, but then we added 60 more pages for the model. So it had more material, more heterogeneous material, so we got the character error rate a little bit less. Or this is a big drop if we are concentrating about the amount of the percentages. So we got as low as 17%. And here's the example, how does it look? The upper part of the slide is the picture, and then we run the model for this picture, and in the bottom part, it's the text the model generated. So this part here is just only automatically recognized. But as you can see, well, this is Finnish, but you can see that there are some errors. So, for example, there is the line here, and here there's a letter H missing, and there are other errors as well. So it's not perfect, but you can basically read these texts without the picture at the moment. So then the other example was the crowdsourcing project with the genealogists, and this is an example page of that material. And this material is renovated court books, which means that there are a lot less hands in these texts. So basically, it would straight mean that the model would work better. And if you see the numbers there, we had 125 pages transcribed for ground truth and for the model, and we get the character error rate as low as 12%. After that, we added 75 pages more and got character error rate down to 9%. And this character error rate 9% is basically a really good level where we can provide the material as a full text search, and the fuzzy search works really well. You can find almost every word in this text when the character error rate is this low. And here's the example of how this model worked. We can see that this text is in Swedish, and this is even more, for example, human readable without the picture. But still we have some errors there, but not as many as we had with the war diaries. So the conclusion is that the crowdsourcing we had with the genealogists, it wasn't that huge that we have had hundreds and hundreds of users, but we mostly had, first of all, we had plus 20 users, and in the end of the project we had only a couple of genealogists providing the rest of the let's say 80 or 60 pages out of the 125. So basically with crowdsourcing we don't need to have a lot of people coming and participating, but we need to have those enthusiasts who do most of the work, and the results can be really, really good. Well, then the other part with the crowdsourcing was the large-scale processing. That we have the 70 million images or pictures at the moment, and in the READ project, we decided with the project team, with the other technical universities, that we should do the large-scale processing with two different collections. Both of these collections we've selected are kind of huge. One is 1.5 million images, and other I would say around 700,000 images. The 1.5 million images is the poll text records from the 19th century. I will show you an example of it. And the 700,000 images are those renovated court books, which I just showed. The poll text records, why we decided to have this in the large-scale processing is because it's from the same era, but it's a lot different. It's not just text, but it's in table form. And in the project, we have been developing tools for interpreting the tables, the rows and columns, and one aim is to get out the data from the tables and get it in some kind of more modern form, that it's not just text you can search, but in for example you can take it to database or something like that, and provide even more complex searches for the data. Then a couple words about the phases we had or what we are going to do or doing at the moment in the large-scale demonstrators, the large-scale processing. We have been doing this for this spring, and the idea is that we build models from the same material or from the same material step by step, adding more and more ground truth. And when we build a model, we test it and see how the character error rate and develops. If we add 50 pages, we can see that, well, we can drop the character error rates, for example, 2% or so. And we continue to do this so long that we can't see any progress with adding transcriptions or ground truth for the model. And that's the one goal, but the other goal is to figure out what is the decent level for the character error rate, for example. I think that I told that the 9% is really good, and we can do full text search and fuzzy search for the content, but there are still some problems, and we need to figure out if the character error rate 9 is good, or should we aim for 5 or 8, or is 12 good enough. We also need to see what are the costs by generating better and better models and generating more and more ground truth. And when we have the decent level, or the model doesn't improve anymore, then we start to run the model for larger and larger amounts of images and pictures. And we need to also to test how it works with the huge collection, for example, the 700,000 images. And then we can see how much it takes, computing power and so on, and what it costs after all. And the part which is kind of not involved in the READ project at the moment is the large-scale processing or the large-scale demonstrator, which concentrates on sharing the models, the generic models or so. So if we just broaden a bit the perspective in this work, we can say that our aim in Finland is that when we produce models and better models, we aim that we could publish these models so that they could be open and accessible to anyone. And by anyone, I mean persons, single researchers, or institutions as well. And just 2 weeks or a week ago, we did some tests with the material from the Swedish National Archives. The material is open, it has the same language, Swedish. It's this material is from the same era, and it's kind of same material. It's also Dombecker, which is can be court books, and from the 19th century. And the material looks like this. It looks pretty similar with our court books. And what we did is that we used our National Archives of Finland model from the court books for this material, and we got the character error rates to 10 to 15%. This is just an estimate. We haven't measured it yet, but it's not 9%, but it's just a little above it. And this character error rate, 10 to 15%, is really good, if we are honest. And how this material looks, again, the same example about the picture and the automatically recognized texts. So, as you can see, there are errors, and as you can see, there are more errors than in Finnish material. But it's still the text below. It's still, I could say, it's readable by human at the moment. So I've told you about the full text search or the fuzzy search about the context. A couple of words. In the READ project, we have also development different kind of tools for searching the content, and this example is concentrating on a thing called keyword spotting, and the keyword spotting is useful then when we can't get the character error rate as low as, for example, below 10%, and at those moments we can use the keyword spotting and provide different kind of search results for the end users. And in this example, we have used the material, the court books, and from Sweden, and we tried to find words äktenskap, which is in English marriage, and we got 5 results presenting the page number, so-called on what page there is probably a word äktenskap, and then the confidence, how the tool estimates that there is, for example, 20% chance that there is written äktenskap. And we have selected this result from the page 22, and it shows the picture of the word. So as you can see, it says äktenskap, the marriage. It's correct. And in the example, we have the line transcription. You can see that the model hasn't understand that there really reads äktenskap. It has uktenskapes. And with this keyword spotting, if you try to do the full text search or the fuzzy search with word äktenskap, you can find anything. But if you use the keyword spotting, you can have a lot higher character error rate and provide this kind of search results. The balance here is that if you want to use the keyword spotting, the search results are not instant. For example, in this collection where we had 25 pages and 1 word, it took 5 to 10 seconds to generate this result, and it gets longer and longer. For example, if we have material, for example, 5,000 pages and 2 keywords we want to find, it might take 5 minutes or 10 minutes, but it's still a lot shorter time than just go through the whole material and find, for example, certain person name or place name or event or so. So with the keyword spotting, we can provide keyword search even for material where the character error rates is 30 to 40%. It's at the moment it's estimate, and we need to figure out what's the good level for character error rate to provide a keyword spotting. And of course, the conclusion is always related to material. Is it enough that we provide the keyword spotting, this kind of use to material, or do we need to provide full text search, fuzzy search? And basically this means that if the keyword spotting is enough, we don't have to put so much resources and money for providing search for the content. And then just the last words related to that, what we have learned in the READ project during 2.5 years. And in the project, we have a really strong feeling that the project will end at 2019, in mid-2019, and we are moving to a service phase. So at the moment, we are planning on some kind of cooperation model with the partners in the project. And the cooperative would provide a service from READ after the project ends. And at the moment, we in Finland, we see ourselves as a part of the cooperation. So we can say that we are a service provider in 2019, but partly we are also a customer, because we will have, or we have needs for handwritten text recognition, and we will be, we are aiming for that we would like to use the technology in the future as well, not just in the project, but after the project as well. So at the moment we are planning it this year and next year. The aim is to integrate the whole READ platform to be part of our core processes. So the handwritten text recognition would be a part in some phase for some material in the long run.
Okay, if there's no more questions, we can thank Vili.